Welcome to Study Loop.
For the following, we're asked to find the frequency, the energy in terms of keV, and the wavelength. So frequency is given by the Moseley's law, which says that frequency f is equal to 2.48 times 10 to the 15 hertz times the atomic number z minus 1 squared. Once we know frequency, we can get energy, because energy E is equal to Planck's constant times the frequency. And once we know the frequency, we can also get the wavelength, because wavelength is equal to the speed of light, c, divided by the frequency, f. So for z equals 20, we simply have to put 20 value of z, the equation frequency. In this case, we find that the frequency is equal to 3.7 times 10 to the third hertz, the same as 3.7 times the third electron volts, which is the same as 3.7 keV, kiloelectron volt. We're going to put things in E, so let's write it in keV. Next, calculating the energy is equal to Planck's constant, which is equal to 4.136 times 10 to the minus 15 electron volt seconds times the frequency. Oh, I'm sorry, and I made a mistake. So I said frequency is 3.7 eV. That's actually the energy. I got a little ahead of myself, and you probably noticed that when you plug that in, that didn't work. So again, calculating frequency, 2.48 times 10 to the 15 hertz times z minus 1. Z is 20, so this is 20 minus 1 squared, gives you 8.95 times 10 to the 7th. Sorry. 8.95 to 17 is the frequency that we're dealing with here. So now that we know frequency in units of hertz, we can calculate the energy, because E is equal to constant times the frequency. Planck's constant is 4.136 times 10 to the minus 15 electron volt seconds. So 3.7 times 10 to the electron volts, or 3.7 keV. And we can also calculate the wavelength from the frequency, since wavelength lambda is the speed of light by the frequency. The speed of light is 3 times 10 to the 8 meters per second. So this gives us 3.35 times 10 to the meters. We box that in as our solution, the final part. Now for B, we're doing the exact same thing, but this time Z is equal to 27. So we plug in 27 to our equation for frequency, for our Z value, and this gives us a value for our frequency equal to 1.68 times 10 to the 18 hertz. Now using for the frequency, we can get energy constant times the frequency. This gives us a value of 6.93 times the electron volts, or 6 keV. We can box in. The second part is our solution. And the wavelength is equal to speed divided by the frequency, 10 to the 8 meters per second for the speed of light, and we get 1.79 times meters. And lastly, when z is equal to 48, we plug in z equals 48 into our equation for frequency. And in the situation that the frequency is equal to 5.4 times 10 to the 18. So we know our frequency, energy, and wavelength. Again, in Planck's constant times the frequency, and our new value frequency expression, we find that the energy is equal to 22 times 10 to the 3rd electron volt, 2.7 keV. Wavelength is equal to this divided by frequency. So plugging in frequency, we find that this is equal to 0.0547 times 10 to the minus 9. So let's write in terms of nanometers. So this is 0.0547 nanometers. You can write the other ones in terms of nanometers if you want. This is 10 to the minus. We wrote them in meters, but either way is correct as long as your expression for units is correct.